Hello everyone, myself Maithili Deurkar from Sri Shivaji Science College Amravati. My seminar topic is dyes and its classification. Index. Introduction of dyes. Condition for a colored compound to act as a dye. What are dyes? Classification of dyes. Classification of dyes on the basis of structure. Classification of dyes on the basis of application. Introduction. Dyes are colored organic compounds which when applied to the fibers gives it a permanent color. Dye is resistant to action of light, water and soap. Dyes used to impart color to various substances including paper, leather, fur, hair, drugs, cosmetic waxes, greases, plastic and textile materials. Conditions for a colored compound to act as a dye. Presence of chromophore. The dye has a color due to the presence of this group. Chromophore examples are N double bond O and bond N double bond N, etc. The compounds bearing chromophore are called as chromogenes. Second, presence of oxochromes. Dye must be attached to fibers by means of stable chemical bonds. These bonds are formed by some acidic or basic groups. Such groups are known as oxochromes. What are dyes? Dyes are colored substances capable of being fixed to fabric like silk, wool and cotton and other substances such as paper, leather. When fixed, dyes must be fast to light and resistant to the action of water, dilute acids, alkaline solution and bleaching. Classification of dyes. Dyes are classified in three different ways. Classification of dyes on the basis of structure, classification of dyes on the basis of mode of application. Dyes can be classified into acidic and basic depending upon the oxochrome present. Classification of dyes on the basis of structure. Depending upon the type of chromophore present in their structure, the dyes are classified into following main types. First one, nitro and nitrous dyes. Second, azo dyes. Third, triphenylmethane dyes. Fourth, phenolphthalein dyes. Fifth, indigoid and thioindigoid dyes. Sixth, anthraquinone dyes. Seventh, miscellaneous dyes. First, nitro and nitrous dyes. These dyes contain nitro or nitrous group as the chromophore and bond OH as oxochrome. Colors of these dyes are not fast and hence industrially less important. Example, naphthol yellow, picric acid and naphthol green. Naphthol yellow is one of the dye used for coloring edible materials. Azo dyes. This contains one or more azo group as chromophore. Autochromes present in these dyes are bond OH, bond NH2 and bond NR2, etc. It possesses a wide range of colors from yellow to orange and red. Example, methyl orange, Congo red. Methyl orange. It is an acidic azo dye because it contains sulfonic acid. It contains one azo group. Sulfonic acid group make it more soluble. This group act as a oxochrome. IUPAC name is dimethyl amino azobenzene sulfonic acid. Preparation. First step is diazotization of sulfonyl acid. Step 2 is coupling of diazo compound with dimethyl aniline. Properties and uses. Water is soluble because it contains acidic sulfonic group. It is not sufficiently fast to light and soap, hence it is used as a dye. It is generally insoluble as the sodium salt, which is used as dyeing. Imparts orange color to silk and wool. Indicator in acidic alkaline titration. Triphenylmethane dyes. The central carbon atom joining the three aromatic ring on paraquinoid and two are benzene rings and quinoid group is chromophore. These dyes have intense colored but this color fade rapidly in light, so these are not useful in textile industry. Used for coloring papers and typewriters, ribbon, etc. Example is melanchoid green, crystal violet, methylene violet, etc. Uses: it is manufacture of ink, stamping pads and typewriter ribbons. As an indicator to find H positive ion concentration of solution. It is used as biological stain and making pencils. Gentile violet is used as antiseptic for certain skin diseases like burns, ulcers, and also used for washing the wounds. Phenolphthalein dyes. These dyes are formed from phthalic anhydride and phenol in presence of dehydrating agents like ZnCl2 or concentrated H2SO4. Chromophoric groups present in these dyes is triphenyl methane structure. For example is phenolphthalein. Fifth is indigoid and thioindigoid dyes. Indigoid dyes contain carbonyl chromophore. Indigo is best example of these dyes and obtained from plants. Indigo is dark blue amorphous powder with copper luster. It is used as large scale for dyeing cotton by wet process. Thioindigoid is similar to indigo but differs in one respect, that there are two S atom instead of one NH group. Thioindigoid is used to dye cotton, polyester and wool. Example of this is indigo dye and thioindigo dye. Anthraquinone dye. Chromophore is paraquinoid. Alzarin is typical anthraquinone dye. Alzarin obtained from root of madder plant. Now it is produced commercially as a synthetic dye. Preparation of alzarin in three steps. Step first is preparation of anthraquinone. Second, sulfonation of anthraquinone. Third step is conversion of 2-anthraquinone sulfonic acid into alzarin. Second is classification of dyes on the basis of application. Direct dye or substitutive dye. Indirect dye or modern dye. Ingrain dyes, wet dyes and disperse or reactive dyes. Direct dyes carried out in natural or slightly alkaline dyed solution. It contains acidic or basic oxochromes. Polar in nature, used on cotton, paper, leather, wool, silk and nylon. Example is Martinez yellow. Indirect or modern dyes. These dyes applied to the fabric with the help of the salts. Example oxides of chromium or aluminium. These salts are modern from an insoluble coordination complex between the fibers and the dye and binds the two. The insoluble complex compound appears in the form of lac that are fast to light and washing. Example is alzarin. Third one is ingrain dyes, also called as developed dyes, because the dye is developed within the fabric. This method produces quite fast color complex. Example is azo dye. Wet dyes, insoluble in water and soluble in hydrosulfide. Great affinity for cotton and fibers. Example is indigoid. Fifth one is dispersed dye, which means reactive dyes. Dispersed dyes is insoluble in water but can be dispersed in colloidal form in water. Dispersed dyes are used with modern synthetic fibers such as nylon, orlon, polyester and cellulose acetate. Example is nitroazo and anthraquinone dyes. Thank you.